All right, I debated a lot before I decided to do this assignment this way. I could have had you do it on paper, and I could have had you do it in the graphing calculator, but I think you might like this, number one, because I already did the data tables for you, so all you have to do is do what the graph asks you. You're going to be doing number one, which tells you to compare the voltage and the amperage in a tungsten lamp filament and then draw that graph and see what it looks like. That's the first one you're going to do. The one I'm going to do for you is number 24. That's the first one. And it compares the melting point of a certain alloy with the amount of lead in it, the percent of lead in it. And I was wondering, what kind of an alloy would that be? Because lead melts at 621 degrees. The only thing I could figure out, it would be some kind of a solder. So here's how you're going to do it. You select from the letter that it's standing for, and you select the data. Then you go to Insert, and we're going to insert a scatter plot. And if you notice, it looks linear, and in fact, if we right-click on it and add a trend line, we can see what that, I'm going to display the equation on the graph, so that we can see what kind of a line it is. And in fact, it gives us the coordinates of the line. Now actually, it says y, but if you look, the y-axis is actually the temperature Celsius, and the x-axis is the percent. So I just changed those letters so that it makes more sense. Tell you what, I think I'm going to change the title of the graph too. I'm going to call it temperature versus percent lead. I like that. That'll help. Okay, let's look at the next one. You are going to do number 26, so I'll do number 25. And what it is it's a steel wire in tension, and we're going to see how much deformation there is in inches for the amount of compressive force there is on it. So I'm going to start at the epsilon and record to the sigma, do those two letters, and then I'm going to insert another scatter plot, and you're going, to see that once again it appears to be linear, and I'm going to add that linear trend line and the equation, and I'm going to change, I can't change the letters very easily because the y is actually sigma. I'll just use S for that, and the x is actually epsilon. If you notice, it's a very small number. In fact, it deforms very, very, very little per pound of force, which kind of makes sense because you don't want wire to be stretching very much. Otherwise, it would not be a very good thing to use, would it? So then you're going to do number 26. Let's go to page 163, and we're going to use the graphing. The Excel graphing to solve these two. If you notice, it asks us to go from -3 to +3, and I'm going to show you how you're going to do it, because the equation says y equals 3x plus 1. I'm going to go up here and write y equals 3x. Oh, you're doing number 1. Ooh, I would better not do that. I'll do number 2. Y equals 2x minus 2. No, boy, I almost did your assignment for you. Okay, and what I'm going to do is I'm going to take 2 times, because if you notice, it's 2 times the x. So I'm going to click on the x box. Oops, I forgot to put in equals. Equals to, the only way Excel works is if you put it in equals first. 2 times the x box. 2 times the x box, subtract 2. And when I get that, what I can do, now this is where Excel really works good. You don't have to even enter any more data, because I'm going to go to the lower right hand corner and see how my white cross changes into a black plus sign. So when it changes into a black plus sign, I can drag it down and it will graph all of those points. And it says connect them with a smooth curve. So I'm going to start here and graph that, insert a scatter plot, and there's our scatter plot. Now I'm going to move this one down because if I don't, you can see you won't be able to see all of the stuff at the same time. All right. And I could even put in that trend line and the equation for the trend line. And what's interesting about that is when I put it in, it's exactly what I wrote, y equals 2x minus 2. So we could kind of use that as a check of our work. You're going to do number 4, so I'm going to do number 3. How does that sound? So once again, I'm going to write the equation here, y equals 3 minus 2x. And so in this box, remember to turn on the equals first. That turns on the calculation. 3 subtract 2 times, we have to put in the times sign, the negative 3, which is the x spot. And go to the lower right-hand corner again and pull it down. Okay, so, and then I'm going to graph that equation. Insert a scatter plot graph. There it is. I'm going to pull it down so that you can see the graph. I'm going to add a trend line. Notice I clicked on a dot. Add a trend line. Display the equation on the chart. And y equals negative 2x plus 3. If you notice, that's a different order than the way they wrote it, isn't it? But that's because they always write stuff in the standard form, and we did not write this equation in the standard form. You're going to do 4. Tell you what, I'll do number 5. That one's pretty interesting. Y equals x to the second. I'm going to use the caret for the to the sign. So equals this number, and then the to the is the shift 6 to the second. And negative 3 squared is indeed 9. So I'm going to pull that down. Now, when I graph these, this is going to be really cool. You're going to love this. Insert a scatter plot again. And, oops, I'm going to show you that when I add the trend line, I'm going to make it a polynomial trend line of order 2 because it's x squared. And I'm going to display the equation on the chart. And if you notice, it says y equals x squared. Now it says plus 7 to the negative 15th. I don't know why it thinks it needs to have some kind of a common term because it doesn't. But that's what it is. Okay. That was number 5, right? Okay, you're doing 6. You're doing 7. I'm going to do number 8. Just to show you how cool it gets. Y equals x to the second minus 7 times x plus 10. Oops, 10. Now watch this. Equals, remember you have to turn on the calculator first, this number squared. Then it says minus 7x, so minus 7 times that exact same number, and then add 10. And now when I graph that one, you can see that my graph, let's see how it looks here. Can't see it very well, can you? But when I add a second order trend line, polynomial second order, display the equation on the graph, sure enough, there it is. Y equals x squared minus 7x plus 10. So you can do those assignments. I'll show you one more thing, and this is the main reason why I wanted to do this, because I have never been real impressed with the graphing calculator's graphing function. So I want to show you how to do these problems that you're supposed to do number one, and so on, and then solve them, or let's see, resize them if needed. Okay, so number 2 is y equals 4 minus 2x to the second. So equals 4 minus 2 times our x value to the second. I'm going to pull that down, and now when I graph those two items, I'm going to make it smaller so that you can see the graph. Insert a scatter plot, and I'm going to add a trend line, and in fact it's a polynomial order 2 because it's second degree, and I'm going to display the equation on the graph. And if you notice, it is y equals negative 2x squared plus 4, which is a switch around of the way that they asked us to do it. I'm going to do number 10 because this is where it is really, really helpful. So our equation y equals 3.73 minus 1.77x to the second. So I'm going to write it equals, remember that turns on the calculator, 3.73 minus 1.77 times this value to the second. Okay? I'm going to pull that down, and when I graph it, let's see how it looks. So I'm going to start at the x and go down to the negative 40. Insert a scatter plot. I'm going to make it so that you can see the whole thing. I'm going to add the trend line, polynomial of order 2 because it's to the second, and get the equation on the line, and it comes out. Now, if you notice, they have a constant term that it added because it couldn't quite figure it out. But if you notice that constant term, 4 times 10 to the negative 15th is pertinent or 0, and so you might as well just consider it 0. Hardest ones, number 14 through 17. I'm going to do number 15 just to show you why these are a little bit harder. It says y equals 7x squared minus 14x plus 22. Okay, so equals 7 times this value to the second, minus 14 times that value plus 22. When I pull that down, let's see if we can get a graph of that. Insert a graph of that. And if you notice, it shows the graph. Let's add the trend line, polynomial order 2, and the equation, and 7x squared minus 14x plus 22. Now, it says, the book says it wants us to, it says it wants us to find the maximums and minimums, which if you notice, it's not going to have a maximum value, and it's not going to have a 0 because it never crosses the line. It gets close to the line right here. What is that minimum value? Well, if you look at the table of values, you can see the minimum was at 15. That's as low as it got, and it appears as though that's true because if you notice on our graph, this was 15, this is 22, and this is 22. So this distance and this distance are equal, which means this must be the minimum. 15 is the minimum. It doesn't have any maximums, and it doesn't have any zeros. Oh, none. It has 0 zeros. Number 17. Hardest one. You don't even have to do the hardest one. So there. Y equals 5x to the 4th plus 13x to the second minus 31. Now, equals 5 times the x value to the 4th plus 13 times the x value to the 2nd minus 31. If you notice, actually we might have gotten lucky here and have a graph that we can have some 0 values and some negatives. Let's graph these. Insert a scatter plot. I'm gonna move it out of the way here. I'm going to insert click on a dot, add the trend line. This time I'm going to make it a polynomial order 4 because if you notice it's to the 4th. And then I'm going to add the equation, and it says let's see here, 5x to the 4th. It does have an x cubed term that it tried to get, but if you notice it's pretty close to 0. 13x squared. It's got an x term pretty close to 0, and then it's got a negative 31. Now here's the part that you might not notice, because as you get closer and closer to 0, there's some stuff here that must be going on that we don't know what it is. So what I'm going to do is let's see, how should I do this? I'm going to make some points that are around negative 1. I'm going to make it negative 0.8, negative 0.5, negative 0.3, and then I'm going to go the other way, positive 0.3, 0.5, 0.8. Let's see what happens now with our graph. If you notice, it changed it so that it's only going from negative 2 to positive 2 now, because that's where the graph gets interesting. And it doesn't appear like there's any changes in the curve here. It does have a minimum, and the minimum appears to be pretty close to 0. If you notice, our 0 is the lowest value that we've got so far. But let's do some more changing, because I wonder, as you get even closer to 0, how it changes. So I'm going to make this negative 0.005. Oops, I'm sorry, just 0.05. Negative 0.01. 0.01, and 0.05 just to see if that made our graph change any. It doesn't appear like it did. If you notice, we are below 0, okay? And it does appear as though it was our negative, or our minimum value is negative 31. That does appear to be our minimum value, because if you notice, they do get very close to that. But we haven't discovered where our zeros are. So let's go back in here and let's find if we can find the zeros. If this is 2, okay, at 2 we're at 101. I'm going to show you what does that mean. Oops, I'm sorry. That shows us that on our graph it's going to cross somewhere between 1 and 1.5. So let's guess 1.2. 1.2. 1.2, it's a little bit below that, so let's say 1.3 instead. Then it's a little bit above the 0, because if you notice, here's our 0 line right here. So at 1.3, we're at 5.5. At 1.2, we're at negative 1. So it's going to be between 1.3 and 1.2. Let's try 1.25 and 1.26. Nope, I'm sorry, 1.24. I went the wrong direction. How about 1.23? I want to get below 0, 1.22. There we go. So we're a little bit below 0 with 1.22. 1.23, we're a little bit above 0. So it's somewhere between 1.22 is one of our zeros and 1.23. 1.22 is one of them. Let's go the other way and find the negative zeros. Well, it's probably going to be right around those same spots. Let's try negative 1.23 and negative 1.22. If you notice, those are the exact same values, so our other zero is at negative 1.22. So we've got a minimum value and some maximums, and that's how you do those kinds of problems. Kind of interesting stuff.